So without further ado, I'll hand it off to our presenters. So today's topic is building community for fairness and ethics in AI. And for our presenters, we will have Alisha Zachariah, Kerri Anderson, and Ronak Mehta. So Alisha and Kerri are data scientists on the machine learning research team at AmFam, while Ronak is a graduate student in the computer science department at UW-Madison, who interned last summer and has an ongoing collaboration with the AmFam team. So I'll go ahead and stop sharing my screen, and Alisha, whenever you're ready, you can go ahead and take over.
Yeah, thanks, Chris. I will share my screen. And thanks for everyone that's here. Let me see. There we go. All right, so tell me if my screen doesn't look okay. Otherwise, I'm assuming it does. Yeah, so thanks everyone that's here. We're really looking forward to this discussion and getting to know some of the audience members today. Thanks, Chris, for the introduction. And we were gonna tell you guys a little bit more about us as well. So I'm Alisha Zachariah. Like Chris mentioned, I'm a data scientist on the machine learning research team at AmFam. And I see some of our team members on the call as well, which is cool. I was a graduate student at the Department of Mathematics, and I graduated in 2020. And my interest in fairness, it's kind of developing fairness and ethics in AI. And I took over the fairness seminar that Ronak started last summer. And with that, the fairness seminar is an internal AmFam seminar, but more about that to come. And with that, I'll pass it to Kerri to introduce herself.
Hi, everyone. My name is Kerri Anderson. I also an employee at American Family Insurance, working on the AI and ML research team. I recently joined the team. My background is in mathematics and statistics, and I've worked at AmFam for several years, and the most recent department I've worked in is in enterprise risk management, specifically focused on model risk management and model governance. So working on that team, I had some good collaboration with business partners across our enterprise to focus on responsible use of data and AI. So between model governance, model risk management, and responsible use, it definitely piqued my interest in fairness and bias in AI. So I'm excited to be here today and to have some good conversations with each of you. And then I'll pass it off to Ronak.
Everyone, yeah, I'm Ronak. I'm a grad student at Madison right now. And I guess my experience with fairness is maybe just slightly more than the others. I guess I started kind of getting into it about a year ago. And then through the AmFam internship, got an opportunity to work on some tools and like a toolbox for kind of analyzing and deploying kind of fairness methods and models. And through the last semester, I've been kind of continuing an ongoing collaboration, working on developing kind of newer and more interesting kind of methods for analyzing and accounting for fairness. So I guess my background is a bit more on the technical side, but I think all aspects of fairness that hopefully we'll talk about in depth later today will, I guess, they're all important to me, and I'm excited to talk about them. So yeah, we can jump into the next piece.
Yeah. So a little bit about what to expect today. So as we were preparing for this, all three of us kind of agreed, this is like, we don't want to present to you as experts. Like all of us feel like we're still learning. And so that's why we kind of based this discussion heavily off of references that were kind of in that Google Doc description that you might have seen. So rather than us presenting expertise, it's more about us going to be asking leading questions that draw heavily from those references. And also in terms of the format, so, we're not going to be kind of like talking at you since we don't feel like experts, but rather, so it's not going to be a panel discussion or anything like that, but more a back and forth. So we'll have 3 sections to this discussion, and each section will have a short talk followed by a breakout room. And Kerri, Ronak, and I will host one of those breakout rooms. And in terms of, how much interaction to expect. So at the minimum, so we would love it in the breakout rooms if, you know, we have face-to-face, we can turn on our cameras, introduce ourselves, but you know, at the minimum, expect to maybe introduce yourself at the breakout room, if not interact more than that. So, you know, if you want to kind of turn off your camera and grab lunch, maybe you can hang out in the main room, but in the breakout rooms, there'll be a little bit more sort of interaction than that. So, also the other thing is we don't expect that you've like read or gone through all the references that were mentioned in the description. And that's kind of why we'll have like a short presentation in each section to kind of give us an overview of some of the material in those references. And with that, I think, right. So just the agenda for today, like I said, there's going to be 3 sections, and we've divided them into kind of the what and the how and the who. But these divisions are more just to give our conversation a little bit of structure. They, like, as we were preparing for this, we felt like they're not mutually exclusive and there's a lot of overlap, but that's to be expected. And with that, I believe I can just hand it off to Kerri to start with the first section.
Yeah, sounds good. Thank you, Alisha. And thanks for our hosts at the UW for having us here today. I'm excited to be joined by all of you and to take this time to have some open, productive, and thought-provoking discussions around fairness and bias in AI. As Alisha had mentioned, none of us presenting today are experts in this field, so we won't be giving a lecture on fairness and bias. Rather, we'll be bringing some information to the table that we hope will facilitate discussions with each of you on where we stand today and what's happening in this space. So from the academic perspective and the industry perspective alike, helping to identify, measure, mitigate, and prevent some of the bias that we're seeing with AI and ML algorithms that are being used and deployed today. So if we go to the next slide, please. So this content before you is information from Coursera's course called How Google Does Machine Learning. And I thought it was a really great example of showing how widespread AI and ML are across a number of industries. And as you know, even though there's a fair number of examples shown here, this is really just a drop in the bucket of what's out there in production today. So if we click once, we'll see some examples that get sort of an immediate green light. So these are pretty useful, fairly intuitive, and they feel like they can bring improvements about to existing processes. They're also more focused on things such as process optimization, and they're less people-facing. So the ones that I've highlighted show demand forecasting, aircraft scheduling, which Alisha will argue whether that's could use improvement or not, and then energy demand and supply optimization. One more click, I've highlighted some examples in red boxes where I sort of take a bit of a pause. So when we think about these algorithms and how they might be used, we consider the information that's feeding them and the decisions that are being made as a result of the output. We kind of go, wait a second, these seem a little bit more ripe for misuse. And there's definitely potential here for an algorithm to act unfairly or in a biased manner. So these algorithms also will certainly impact individuals as a result of their output. So the things that I've highlighted include patient triage optimization, credit worthiness evaluation, and customer specific pricing. So they kind of make you go, Hopefully you guys are out there smiling at Kermit showing up in the presentation. So the next slide. In 2016, author Cathy O'Neil released a book called Weapons of Math Destruction. For the purpose of this discussion, we frame the what in terms of Cathy O'Neil's definition of weapons of math destruction. The topic of fairness and bias in AI go beyond what's outlined in Cathy's book. However, her definitions of weapons of math destruction help us really to put some concrete language around these concepts, and so that's why we're using them illustratively today. So I thought that this quote was worth reading as it sums up the theme of her book, in that the use of such algorithms, while not completely understood and not well known in the general public, are certainly impacting the lives of individuals and groups of individuals in negative ways that we must address. So we can read this quote together. The math-powered applications powering the data economy were based on choices made by fallible human beings. Some of these choices were no doubt made with the best intentions. Nevertheless, many of these models encoded human prejudice, misunderstanding, and bias into the software systems that increasingly managed our lives. Like gods, these mathematical models were opaque, their workings invisible to all but the highest priests in their domain, mathematicians and computer scientists. Their verdicts, even when wrong or harmful, were beyond dispute or appeal, and they tended to punish the poor and the oppressed in our society while making the rich richer. So in the next few slides, I'll use more examples from Kathy's book to tee up our conversation from our breakout room. So what is a weapon of math destruction? Kathy O'Neill defines it as having three key components, which are they are important, secret, and destructive. They're important given that they're widespread, scaled, and used on a large number of people. They're secret in that people may not know they exist, much less how they work. And they're destructive given that wrong decisions can be destructive for an individual and can also create feedback loops to exacerbate bad decisions on a societal level. So on the next slide, we'll dive a bit more into what's meant by important. So when we think about these algorithms making decisions, we think about how they can impact the lives of individuals or groups of individuals. So these include things like algorithms being used to make financial decisions. Should a candidate receive a loan, credit card, housing, or insurance? Employment decisions. Should a candidate be considered for a job, a promotion, or even a layoff? Liberty. Should a candidate be sent to prison or considered for parole? Can we estimate their likelihood to reoffend? And information, when we consider what's on a person's online environment and what type of news sources or information do they see and are they being fed? So it's important to know that these things are not just theoretical. Algorithms are being used to make a number of decisions that impacts people's lives today. And as it currently stands, while there are many groups pushing for overarching principles, regulations, and standards, in the US, there are not laws in place to govern AI and ML and how it's used and monitored on a large scale across many industries. So on this slide, you see some examples of headlines where AI and ML sort of went wrong. And this gives a peek into the examples that are outlined in Kathy O'Neill's book, The Weapon of Math Destruction. So I wanted to leave you with one quote from Kathy to sort of part ways before we go into our breakout rooms. But she states, data science does not just predict the future, it causes the future. And to me, I think as data scientists and AI ML practitioners, and also as leaders within our industries, we really need to consider the data that we're feeding these algorithms, the algorithms that we build, and then the output from those computations and the decisions that are made as a result. These are having very real impact on the lives of others. So it's far beyond just the code that we're writing. It really goes into what's happening out there and our place to sort of make things happen. So on the next slide, this will lead us into our first breakout room, and I will hand it back to Alisha to sort of walk us through what's going to take place next.
All right. Yeah, thanks, Kerri. So just what to expect, we'll have 10 minutes of breakout room. Since this is the first breakout room of the session, we'll probably do introductions and things like that. But yeah, that's pretty much it. 10 minutes of breakout room. Okay, Ronak.
Okay.
Yeah.
Hello. We cut it close at the end there. Sorry about that. I'm back. Yeah, so I think we had some interesting discussions about the kind of introducing everyone, and kind of some of the things that came up definitely were more specific about defining and mitigating bias in a more technical manner. And I guess my background is kind of more technical, so I thought it might be good to have a short session kind of going into brief detail about some of the things that people are talking about in terms of actually kind of adjusting models that exist or training new models that are kind of more fair in some way. So I think the first piece that you might want to kind of think about is how you might measure a bias, or how you might measure something that's unfair. And there are these kind of two ideas. that are kind of like simplistic in some way. So the first you might kind of consider as a naive approach is a fairness through unawareness, or that an algorithm might be fair if and only if there are no protected attributes or group labels that are used in the decision-making process. And this is kind of like a straight, like if you've got your model F, you give it some input and then you get some prediction, it's completely agnostic of anything that might be unfair in some manner, whether it's to a group label or a person's kind of identity, whatever it is, you haven't given it to the model, so it's not something that's being considered. And you can obviously see that this kind of doesn't work in practice because your inputs X might be highly correlated with some of those group labels or group features. And even though you're not directly feeding them into the model, they might still come out correlated. And then you might be just kind of perpetuating a bias that already exists within your data. So then another kind of step forward on this might be fairness through awareness. So you might want an algorithm to be fair in a way that it gives similar predictions to similar individuals in your input data. And this might be just saying if two samples of your data are very close, then they should have similar outputs. Now this seems like it could work generally, but again, you're not kind of using the bias that you know about in your data to inform your model to be unbiased. And I think it might be interesting to go through a very, very brief discrete example of this. So here, let's consider a kind of model algorithm situation where you have people and you want to predict whether they are boxed people or not. So here, the boxes correspond to a true label of 1, and the unboxes are a true label of 0. And we've got two groups, the blue and the green, that is corresponding to the A equals 1 and A equals 0. So you might consider kind of a method or a model that's looking at something that is trying to be fair across the groups in their prediction. So here, the equation at the top is saying that your chance of being a prediction that's true, marked by the check marks here, should be equal between the groups, whether you're in group A or group A equals 0 or group A equals 1. But here is a case where this kind of fails. So if we go through this picture kind of slowly, the check marks correspond to our predictions. And you can see in the top group, we've checked off 8 out of 10 of the blue people. And in the bottom, we've checked out 4 out of 5 of the green people. So by this particular definition of fairness, we are correctly fair to both groups. We are achieving 80% of check marks to both groups. But you can still see that there is some disparity because in the blue group, everyone who is supposed to get a true label or a check mark is getting it. And in the green group, no one who is supposed to be getting the check mark is getting it. So I think it's kind of important to keep this in mind as there are kind of algorithmic or definitions of measures that we can come up with, but there might not be a silver bullet, and there might be situations in some cases where things aren't getting at exactly what we care about. So one kind of a solution to this problem in this particular case is this idea of equality of opportunity. So you might want to be more strict in what you consider a fair, and you might overly care about making sure that if someone should get a box or a check mark, they get it. And this kind of leads to a kind of different situation in which you want to make sure that boxed people are checked all the time for both groups. Now, this can lead to a different kind of loss in terms of inaccuracy, but in terms of being fair, if you care about, let's say, a true positive rate more, then this kind of definition might get you there easier. So I think that's just kind of like basic definitions, but how these kind of plug in can happen in a lot of different ways. So I thought it might be a good idea to just very briefly go through some ways of algorithmically addressing bias. I think that I thought this was a kind of reasonable breakup of the machine learning or AI pipeline in general. Typically, we start with data, then we do some training, and then we have some inference or kind of prediction phase after we've learned the model. And I think it makes sense to think about addressing bias and unfairness at each of these steps, in kind of describing it as a pre-processing, an in-processing, and a post-processing. So I'll just quickly go through one or two kind of ideas in each of these, and we can discuss them more in the breakout sessions. So in terms of the data phase, I think we kind of talked about this briefly in our breakout room. The idea that it's not only about the model that you're training, but the data you have can be biased in its own way. And there are ways that you can kind of deal with this. I guess traditionally, statisticians have dealt with ideas like class imbalance and rescaling and normalization to kind of move the distributions of your input data to be closer to what you'd expect to see in practice, or to kind of move away from what you might call a degenerate kind of solution. So here are just some ideas of what people kind of try to do to make data, I guess, less biased. So this is kind of step one. Then once you've got the data, the training step is kind of where a lot of, I guess, technical interest in algorithmic developments are happening more recently in machine learning, where the idea is that when you are trying to learn your model, when you're trying to minimize some sort of loss over your outcomes, instead of just doing that naively, you kind of do this more direct awareness approach where you incorporate some sort of sensitive information into your training. And this kind of can take the form of a regularizer or some sort of constraint. This kind of encapsulates any sort of method in which you include the sensitive information that you're trying to be agnostic to or fair toward inside your training. And there's a lot of kind of technical details that kind of go into this, but there still is not a one-size-fits-all solution. And there are a lot of kind of idiosyncrasies that can come up in terms of why you chose this over that, or how you train this and that, or hyperparameters. So it's there's cool ideas here, but they need some care. And then finally, of course, once you've trained a model, or if you've given training and you find out that it's biased, there's got to be something that you can do after that. And this is most, I guess, like ad hoc or kind of most direct kind of solution to this kind of problem. So after you've trained the model, or if you're treating your model as a black box, then the only thing you can really do is adjust the predictions that you're getting out of that box. And this is kind of a lot more vague and hand-wavy. So you can't really create too much of a, I guess you might call an algorithmic or like a theoretical solution to this. But this is where you actually are directly targeting what you care about, right? So if you are caring about the false positive rate or the equality of opportunity, here is where you can kind of adjust it directly. But it's still kind of fuzzy. There's still a lot to look at here. So I think like that's kind of all I wanted to technical. But of course, like this isn't the only way of addressing bias, right? It's not just, okay, you have data, you have model, you have code, where can I plug in to be fair? And I think that this is kind of where we want to lead a bit more into discussions about what we as, I guess, people can do separate from the algorithmic pieces. And there's a lot that kind of goes into these pieces in other kind of domains. So standardization and regulation, excuse me, is kind of common in a lot of other fields and domains, but it's not really there in machine learning. And as we kind of talked about in the first session and in the breakout room, this is a space where it's not as technical, but there is a lot we can do here in terms of creating standards that have to be met by certain models or by data or by practitioners. And it's a lot more, it's less technically involved, but requires a lot more, I guess, incorporation of different stakeholders who care about the model being this way or that way. So I think that's all I wanted to say on that. And I'm hoping that we can have some nice discussions in the breakout room.
All right, sounds good. So will we have 10 minutes again for this breakout room session?
I'm looking at the time and we could probably go like 10, 12 minutes because I think we're running on time. Yep.
12 minutes, that sounds good.
Yeah.
So we can meet back at 2 o'clock, let's say.
Yep, sounds
All
good.
right, I'll go ahead and open the rooms.
So I was just saying this in the breakout room, but if you've registered for the discussion, we'll be able to follow up and send you like resources and contact details and ways to sign up for a seminar list and stuff like that. So cool. Let's see. Is Kerri's group back? Oh, there's Kerri. Okay, cool. Yeah, so we have enough time. So I was wondering if we could just kind of talk about what we talked about, like any kind of interesting things that came up in the last discussion. We definitely had a good conversation in our room. I think so. We kind of started off talking about, like the data collection aspect of it and who's represented in those data sets. And then we went on to Brandon mentioning this work in kind of explaining your model after the fact and how that explainability could be a good sort of way to maybe help address this issue. And then we also talked about like issues of privacy, data privacy and that kind of thing. Yeah, curious what was going on in the other groups.
Michael, I'm not sure if you want to step in and share some of what you shared, but we also talked about sort of that, even prior to preparing data and putting it into your model to actually do any type of computation, the step before that is just around like data collection, like who is collecting it, how's it being collected. Michael, do you want to build on that?
No, I thought the summary that even Alisha made from their group actually captured the main points that I was trying to make. So it was nice that they were talking about the same thing.
Yeah, some common themes here. That's good. And then I really like the way we ended our session, leading very much into the question of like representation and who is doing the data science and stuff like that. So yeah, Ronak, did you want to share anything from your group?
A lot of similar ideas. We kind of came to the conclusion that a lot of whatever algorithmic solution you have, oftentimes you're going to need some sort of transparency or explainability that comes with it, because other stakeholders might want to, even if you add your regularizer, if you still got a big black box, they're still going to wonder how it's working. So yeah, I think that was an interesting thought that came up. And of course, definitely leading questions into stakeholders. So I think it transitions quite nicely.
Yeah, you guys set me up well. So I will share the slides again. All right, so the last section is kind of, as we were hinting to, the who in all these questions. And I was saying in my group, like this always makes me think of Dr. Seuss. So we had a Kermit reference and now we have Dr. Seuss reference. But yeah, so how in the last section we were talking about how we effectively address issues in fairness and ethics and bias in AI. And I think this how very naturally leads into the question of who is involved in solving it. So as a jumping off point, consider this quote So it's a quote of Timnit Gebru. And she says, we should make sure that the group of people creating the technology resemble the people who are using the technology. And I would actually, if I may be so bold, I would actually like modify it a little bit and say, they should resemble the people who are affected by the technology and not just the people that use it. And I read this as a statement about the importance of representation. That's kind of, to me, the key point here. And so I recently learned about this term called helicopter research. It was not something I was familiar with coming from this more like machine learning, STEM background. However, I think I really should have known about this sooner, because it does start to become relevant, I believe, in the issues of fairness and bias. So I won't define helicopter research, but rather sort of illustrate it via an example. So a typical example of this phenomenon is when researchers from a wealthier country may publish results about a developing country with little or no involvement from the local researchers. And this typically only contributes to the career of those rich, the scientists from rich countries, limiting the development of local science capacity and careers of local scientists. So probably now you may start to see the parallels with that earlier quote of like, the people building the technology should resemble the people affected by it, right? And this idea of helicopter science, it's recognized to be a bad thing that has been established. Like, we definitely don't want to go down this route. And you can look up all the reasons why it's a problem. But for now, I just definitely want to highlight one sort of key reason, and that is intersectionality. So what is intersectionality? Again, an example. So Kimberly Crenshaw cites this example in her book, Critical Race Theory, and it's also an example that Timnit cites in her talk. So in 1977, a group of Black women sued General Motors for discrimination. And General Motors argued that, their statistics showed that they hired a lot of women and they hired a lot of Black people, and therefore there could be no discrimination against Black women. But what those statistics missed was that they did hire a lot of women, but primarily for secretarial positions, which were primarily white women at the time. And then they hired a lot of Black people, but primarily in factory positions, which those positions typically were for men. So if you looked at that intersection, Black women were indeed getting discriminated against. And so I took this description off of an online source, and it says intersectionality is how aspects of a person's social and political identities combine to create different modes of discrimination and privilege. And I think the point being that discrimination and privilege is not additive, and it kind of like it doesn't respect this nice notion of intersection, and which is why intersectionality can be so unintuitive. And I think it really can go unnoticed if we don't have representation in our communities. And just by the way, for people that might have more of a stats background, the intersectionality is the same thing as Simpson's paradox. So, if you're familiar with Simpson's paradox, you can also think of it that way. But yeah, so we've talked a lot about why, who has a seat at the table, why representation is so important there, but there's a couple of other points that I'd like to bring up. So I think interdisciplinarity is also very important to this question of who has a seat at the table. So in Timnit's talk, so Timnit talks about, working with archivists, who've already done the legwork on all these questions of how to not drown out minority voices and get diverse perspectives. She encourages talking to historians, saying, they could point us to how similar questions have been answered in the past in other fields. She mentions automobile industry, clinical trials. And then she also takes inspiration from electronics for, standardization and documentation. And that's how she kind of like prescribes these data sheets and model cards. But the key point is we don't want to reinvent the wheel. Let's establish protocols, let's get to the solutions sooner rather than later. And I think interdisciplinarity is kind of like a key fact there. And then finally, there's this idea of multiple lines of defense, which is actually something Kerri, I learned from Kerri. That's something in risk management. And the idea is that we have all these stakeholders. So we have the consumers, the model developers, business owners, regulators that are all kind of interfacing with these issues in different ways, and who can all kind of like individually or on their own provide a line of defense against these problems, but they're often siloed. And I think what happens is that it's hard to have these conversations and we're kind of like not talking to each other. And it came up in my breakout room, in the first breakout room, that there are ways in which these conversations are just hard to have. So we need better ways to talk about these things so that, we're not just talking to ourselves and we're talking to each other. And I think kind of tying it back to the title of this discussion session, that's why we need a well-functioning community. And I think it's very important if we want to effectively address these issues. So with that, I believe we can switch to our last and final breakout room.
Sounds good. Would you like 10 minutes for this one? Will this take us to the end?
So we will come back and kind of like just share some resources on ways to connect with each other and connect with communities. So maybe let's say till 2:20.
2:20? Sounds good. Okay, I'll open up those rooms now.
Yeah, I felt like it's always been hard to break away because the discussions have been so good. Let's see. All right, let me share my slides again. So welcome back from that last breakout room. I think the last section, we just wanted to share some resources and ways, to stay connected, either with some of the people you met today, but also with larger communities in the space. So yeah, I can speak to some of these, but I might ask Kerri and Ronak to jump in as well. So one thing you could do is get added to the AmFam Fairness Seminar list. If you're an AmFam employee, you can be on the internal list, and otherwise we have an external mailing list as well. So Kerri, do you want to speak a little bit about Fair Learn?
Sure. So I was doing a bit of searching to try to find some groups that were active in this space, and there did appear to be a lot of like formal groups, like, I don't know, just different companies that are in the space and things like that. But I was like, how do I as a person just sort of get involved and have these conversations? So one resource that I came across that appeared to be good is Fair Learn. So it's an open source community-driven project to help data scientists improve fairness of AI systems. And I believe it's just like open source contributions to Python packages, I think is the right word. They do have weekly community calls every Thursday at 11 Eastern time. So if you check out fairlearn.org, there's some information on their site about how to get involved. So you can contribute code or hang out at the roundtable and see what folks are talking about.
That's a really interesting. I learned about this kind of the community aspect of it just when you mentioned it, Kerri. So that was really interesting to know. And of course, like researchers at UW that we would like to shout out, and whose work you could definitely check out and follow. I know Michael Ferris is here, and Michael gave a talk in our fairness seminar, and had so much cool work on, like the drawing fair districting for sort of to counteract gerrymandering, but also work on fair vaccine distribution with Corey Jackson, that I think is super cool. I know Kai-Ping Chen, who is working with the AmFam Data Science Institute, also has some really cool work in the space. And and Ronak, maybe you can speak to some other folks' work if you want to jump in.
Yeah, I think I don't want to speak too strongly, but I think that you can definitely check out some of Aus's work. He's kind of developed some more practical tools that is, I guess, more targeted toward kind of industry entities, but I think a lot of his work is also absolutely related to kind of addressing and identifying different areas of inequity and fairness. I think there was one more thing that I wanted to quickly plug that's not exactly related, but it's something that I had come across recently that is an event coming up. It's not exactly related to fairness, but I think it could be interesting to the people who have come to listen to us speak. Chelsea Manning is going to be giving a Q&A session at the Union. I believe it's next week. And while she's not really someone who's kind of looked into the fairness and ethics of ML, I think a lot of what she might talk about will overlap in terms of the ethics of advancing technology and kind of just generally the, I guess, like dealing with issues of fairness in our rapidly developing technological world. So definitely check that out if you're interested. I put the link in the chat.
Thanks, Ronak. Yeah, I think so. We did have some of our references. Here are our email addresses if you want to reach out to us directly. But we'll also, if you are registered, we will send a follow-up with, the links to those resources, with our contacts and ways to sign up for that AmFam mailing seminar series mailing list if you're interested. So yeah, I think with that, something in the chat. Yeah, so Chris has some links in there as well. But with that, I think that's pretty much it for us. I know we have a few more minutes, so if people have thoughts, questions, anything.
I think we should first just take a moment to thank our excellent speakers. So thank you so much, Alisha, Kerri, and Ronak. This has been an awesome discussion. And you can use the Zoom reaction feature to clap. It's a little bit less satisfying, but we do what we can. And yeah, I'll leave it open to questions, but also please feel free to check out the links that I posted in Zoom chat. You can sign up for future events. You can check out our newsletter, and I'll leave some time for questions now.
Yeah,
I just wanted to note that Kai-Ping Chen will actually be part of the closing ceremony in 2 weeks' time of the, and so there will be another discussion. And so I think some of the issues that we brought up, she might have a different perspective on and give some of that some of that viewpoint in the closing ceremony. So I welcome as many people who can come to that closing ceremony in 2 weeks' time as possible.
That's a great call out. Yeah, thank you. Yeah, definitely a lot of cool stuff happening even just at the Research Bazaar. So shout that out too. Yeah.
I wonder if there's interest in continuing these kinds of conversations as a regular group. I know you had some resources of folks doing it at AmFam. There are folks meeting regularly about machine learning. issues at UW.
Mm.
But some of us have been also trying to get a regular AI and ethics group together.
Yeah, I mean, I think there will definitely be interest among like the data scientists at AmFam to connect. Do you have a point of contact for that, or?
I mean, me, I suppose, or
Yeah,
I think
I'm happy. Like if we send this out to the attendees, our email's on there. I think we should definitely try to like see where we can spin something up and like meet up. This is something that Ronak and Alisha and I were all kind of discussing is like what's out there, like what can we get involved with, where can we keep this conversation going. So I know from our side there should be interest, and there's a lot of groups at AmFam that we can tap into as well to kind of spread that word. Yeah, but if you know folks at the UW side and we can open it up, I say let's do it. Alisha, I don't know, I kind of jumped in there, but are you feeling the same way?
Yes, 100% on the same page. Yeah, it definitely seems that like there's energy and interest in that. So let's connect after this.
So some of that was to some extent the point of inviting or having the title being communities. Is we're hoping from this Data Sciences Research Bazaar to facilitate the growth of some of these. I'll call out Chris, who's actually tried to start building a group, a collaborative group amongst AI researchers. And if Kerri wanted to touch bases with him about the techniques and the infrastructure that he's used to do that, that would be something that we would be more than willing, and we would like to help help new communities grow where there's interest and a groundswell of opinion. So Robin, Kerri, and Chris could actually all get together and work out.
And Alisha and Ronak and
yeah.
Yeah, this is awesome, you guys. This is exactly what we were hoping for. Like, you know, how do we keep these conversations going? Like, the goal is to keep the conversation going. So this is great. Very
exciting. Or to have like regular talks on the topic or something. There's just a whole community of learning we could do together.
Absolutely, that'd be wonderful. Well, I think from Chris, you should have access to everybody's contact information, so we can.
Yep, please keep me looped in. I'd be happy to help in any way I can and give some insights from what I've learned setting up the machine learning community.
Fantastic.
Awesome.
And then anybody else on the call that's not sort of visible there, if you guys are interested too, please feel free to reach out and get connected as well. Great.
All right, well, we are at time, so feel free to take off.
Thanks
and once again, thank you. Thank you all.
Thank you.
Thanks everyone.